Math 2414, volumes, shells, summary of techniques. I didn't originally plan on doing this video, but at the conclusion of the last one, I think it's a good one to do real quick. Because in general, when you're asked to find the volume of a solid obtained by rotating a lamina around an axis, a horizontal or vertical axis, you have some decisions to make. But the truth is, if you know what to look for, you don't have to make a single decision. You just got to follow a path, and at the end, you do that technique. If you rotate a lamina around a horizontal or vertical axis of rotation and want to find the volume of the resulting solid, here's the two questions you should ask in this order. Number one, is the lamina defined by functions of x or functions of y? Specifically, let's say you have a lamina that has y equals f of x on top and y equals g of x on bottom, versus a lamina that has x equals f of y on the right and x equals g of y on the left. If your lamina is defined by functions of x, you want a cut with a skinny x side to create a dx in the integral. And to get a skinny x side cut, you cut vertically. So for functions of x, you want a vertical cut for a dx integral. Or I should say for integrating dx. But if your boundaries of the lamina are defined by functions of y, then you want a dy integral, which means you want to cut with a skinny y side, so you make a horizontal cut. Horizontal cut for integral dy. So that's the first decision. Which way do I cut it? If it's in functions of x, you cut it vertically. If it's functions of y, you cut it horizontally. Now, how do you know whether to use the shell method or the disc washer method? You answer the second question, is the cut perpendicular to the axis of rotation or parallel to the axis of rotation? If it is perpendicular to the axis of rotation, one second folks, I'm going to circle this in orange over here. If it is perpendicular to the axis of rotation, then you're going to use the disc or washer method, which is the integral of pi capital R squared minus pi little r squared, and it'll be dx or dy depending upon the answer to part one. Just keep in mind that if the axis of rotation is a boundary of the lamina, this part's gone because your inner radius is essentially 0. We'll put dx or dy, whichever one it is. But if your cut is parallel to your axis of rotation, then you're going to use the shell method. Parallel shell. And the shell method is the integral of 2 pi times the radius times the height. And again, that's either dx or dy, whichever the answer to question number one said it was going to be. You just have to remember that in the shell method, the radius is actually the distance from the axis of rotation to the cut, and the height is how tall that cut is. Whereas in the disc and washer method, the outer radius is the distance from the axis of rotation to the further side of the boundary, and the inner radius is the distance from the axis of rotation to the inner side of the boundary. And if the axis of rotation is a boundary, then that distance is 0. This disappears, and it becomes just a disc. With some practice, it's really easy to identify dx versus dy, and then disc washer versus shell. The hard part is remembering what these things represent and representing them in terms of the correct variable. If it's dx, I need both the radius and the height as functions of x. If it's dy, I need the radius and height as functions of y. Over here, if it's dx, I need both radii as functions of x. If it's dy, I need both radii as functions of y. All right, that was fun.